Okay, I'm going to try to make this one short and sweet-ish. So we're talking now about stretching, shrinking, and reflecting the graph of a quadratic function. So what is the effect on the constant a on the graph of g of x equals ax squared? So we're looking at simple enough. So we're going to graph and figure out what it does. So the first examples are to graph each quadratic function that you're given. Again, these are all given in vertex form at this point in time. The graph of the parent function, f of x equals x squared, is shown in gray for you. So this would be the time to go ahead and pause and do this page on your own as much as you can, and then come back. Hey, welcome back. So all I had to do was plug in these values of x into my function and get my values of y. Look how fast I can do my math. And then I can plot my points and sketch my parabola. Do the same thing with the other one. Plug in these values. I get these values for y. Plot my points and sketch my parabola. And now I need to think about what's going on as a changes. So I'll let you read this. So it's saying that if we look at one point and we compare that same point between the two, so we're looking at if we have an input of -1 on the parent function, if we input -1, we get an output of 1. But on g of x, if we put in -1, we get 2 out. So what's going on between the two? How are they changing? Well, it's changing by a factor of 2. So what we could say is that the y-coordinate on the graph of g of x is 2 times the y-coordinate of a point on the graph of f of x. Complicated way to get there. So basically what is going on, well, as we remember from our absolute value functions, the graph of g of x is a vertical stretch of the graph of f of x. And if we really want to get advanced, we could say by a factor of 2. Okay, same thing that's going on here. How does the y-coordinate change for a given point when we've got the same x-coordinate? How does our over on this graph, how does our y-coordinate change? Well, in this case, the y-coordinate is 1/2 times the y-coordinate of a point on the graph of f of x. So in this case, we have a vertical shrink of the graph of f of x. Remember, stretching is like if it was a rubber band, you're pulling, you're stretching it, it gets longer. And shrinking would be just kind of squishing it or compressing, and it becomes wider. Okay, now let's see what happens when a is less than 0. So again, pause, go ahead and go through this page. Well, that didn't take you long at all. So I plugged in these values. I got these values out. I plot my points, and I drew my parabola. Your parabola should look kind of like this. It's not just a reflection, something else is going on. Same with this. I plugged in my points. I got my y-coordinates. Drew my points and sketched my parabola, or plot my points and sketched my parabola. And again, it is a reflection, but it's also something else is going on. So we drew the graph, and what is going on here? Well, the graphs are reflections on the x-axis. We could already see that, but what else is going on? We also have a vertical stretch. So if we look at what a is -2, so that negative is giving us the reflection, and the 2 is giving us the stretch. Same with the other graph, except this time it's still a reflection. Look at that, a -a, but this time it is a shrink. So the graphs are still reflections on the x-axis. However, the graph of g of x is a vertical shrink and a reflection across the x-axis. Okay, so if we want to summarize our observations, what's going on? Well, if a is greater than 1, so if it's 2, 3, 4, 4.5, we have a vertical stretch, and no, it does not reflect. It opens upward. If a, however, is between 0 and 1, so let's say it's 0.5, or let's say it's 1/4, then what we have instead is we have a vertical shrink, but a is still positive. That means it is not reflected across the x-axis. If a is between -1 and 0, we're still going to have a vertical shrink, but now that a is negative, yes, it will be reflected. If a is exactly -1, then it is not going to stretch nor shrink. And yes, because it's a negative a, it is reflected across the x-axis. And if a is less than -1, so it's -2, -3, -5,000, we have a vertical stretch, and still it's a negative number, so yes, it is reflected across the x-axis. Okay, so now this is the trickier part. We're going to write equations from graphs. So the way to do that is we're going to pick a point. It does not matter which point we pick as long as it's a lattice point that we can read easily. If you don't believe me, after this you can pause and test out that point right there, just like I did. So the point that I'm picking is the one that I'm given 2, -1. And we're going to plug that in for y and x. So y is -1. I'll plug that in for y. And x is 2. So I'm going to plug that in for x. So our parent-ish function is we're looking at y equals a times x squared. So we know that we should get -1 equals a times 2 squared, because that's our x and our y here. So if we solve, we should get -1 equals a times 4, because 4 is 2 squared. And now we just need to do algebra. We get -1/4 equals a. So to write the equation, we can say f of x equals -1/4 times x squared. This only works this simply if our origin is our vertex. Because if it's translated somewhere, we've got to deal with that separately. Okay? But as long as the origin is our vertex, it's as simple as this. Y equals ax squared. Take a point and solve. Get your a, and now you've got your equation. Okay, without actually graphing it, though, how could we find out whether or not we're right? Well, what we can do is we can think about what should be happening based on a. Think about that table that you made a little while ago. So if a is -1/2, what should happen? If a is +5, what should our graph look like? So in this case, because a is between 0 and -1, it was -1/4, remember, the graph of the function is a vertical shrink and a reflection across the x-axis. So let's take a look. It's a vertical shrink. Yes, it is, because it's wider. And it's opening downward, so it's a reflection across the x-axis. So that matched, and so chances are our a value is correct. Now here we have an error analysis, knowing that the graph of f of x equals ax squared is a parabola that has its vertex at 0, 0, and it passes through the point -2, 2. A student says that the value of a must be -1/2. Explain why this value of a is not reasonable. Well, we're going to do what we did up here. We're going to think about, well, if it's -1/2, then we should have a vertical shrink and a reflection across the x-axis. So if we just kind of picture that in our mind, oops, that's not in our mind. If we picture that in our mind, we've got our x and y axes, and it should be opening downwards, shrunk. Well, that's not going to ever hit -2, 2, is it? It's only going to hit quadrants 3 and 4. And so if a equals -1/2, the graph of the function would be a parabola that lies entirely in quadrants 3 and 4, all below the x-axis except for the vertex. But the given point, that point that we're testing, lies in quadrant 2. So that means that a cannot be -1/2 if that is a point. Okay, how to do the homework. Okay, so we're going to graph each quadratic function. So f of x equals 3x squared. So our vertex here, if we look at here, we don't have an h and we don't have a k, so that means that our vertex is 0, 0. And I'm going to go ahead and make a table, x and f of x. And as I already said, what happened to my f of x? That's weird. F of x. And so there's my vertex 0, 0. And I'm going to go ahead and pick a few numbers near 0. Why am I not going to the negatives anymore? See if you can figure that out. So in any case, if I plug in 1, 3 times 1 squared is going to give me 3 times 1, which gives me 3. If I plug in 2, that gives me 3 times 2 squared, which is 3 times 4, which gives me 12. If I plug in 3, I get 3 times 3 squared, which is 9. 3 times 9 gives me 27. And now I just need to figure out how am I going to, where do I need my origin to be in order to be able to graph this? My vertex is 0, 0. It's going to be centered, but it's going to open up. So I should probably put my origin somewhere down near the bottom middle. Include my scale. Plot my points, as many as I can. Let me go back on that one. So I plot points. I could only get to 1, 3 and negative 1, 3. So I'm actually, when I graph my parabola, I'm going to not cross this 2 because that's going to be way up there. So I'm going to be very skinny in my parabola and make sure that it doesn't ever cross the lattice line for 2 or the lattice line for negative 2. Okay, other homework is now we are given a graph and we are asked to write the equation. All of the ones that we are given here, we have an origin of 0, 0, so we don't have to worry about h and k, and we are given a point. So we're going to start with our basic function as y equals ax squared, and we're going to plug in our y, our x and our y. So we'll plug those in. We get 5 equals a times negative 1 squared, which is 5 equals a times 1, which means 5 equals a, so a equals 5. Now I can write my function, f of x equals 5x squared. There's my a. Easy peasy, lemon squeezy with mac and cheesy. Okay, no, that's a little gross, never mind. See you guys in class.